Have you ever seen a closed sign at your favorite hiking spot, or a stunning natural landmark and felt a wave of disappointment? You might think, why? It looks perfectly fine. But what if I told you that sign could be the very thing that saves your life? Today we're going to dig deep, literally, into the unseen dangers lurking beneath our feet. Geological instability, and why it's forcing some of the world's most beautiful tourist destinations to close their doors. So, what exactly is geological instability? It sounds complicated, but think of it like this. The ground we stand on isn't a single solid piece of rock. It's a complex, ever-shifting puzzle made of different layers of rock, soil, and sediment. Geological instability happens when these layers lose their strength and cohesion, making them prone to sudden and often catastrophic movements. This isn't just about massive earthquakes. It can be as subtle as a slow, creeping landslide, or as dramatic as a sudden rockfall. Several factors can trigger this instability. First, let's talk about water. Heavy rainfall or rapid snowmelt can saturate the ground, increasing its weight and lubricating the layers of soil and rock. This is like trying to stack wet sand. It just doesn't hold its shape. The water pressure builds up within the pores of the earth, pushing the particles apart and drastically reducing the friction that holds a slope together. Suddenly, gravity takes over, and a whole section of a hillside can give way. This is a primary reason why you'll often see trail closures after a big storm. Then there's the natural process of weathering and erosion. Over thousands, even millions of years, wind, rain, ice, and temperature changes break down rock. Think of a cliff face. Tiny cracks can form, and when water gets in and freezes, it expands, widening those cracks. This freeze-thaw cycle acts like a slow-motion jackhammer, gradually weakening the rock structure until huge boulders can break free with little to no warning. And of course, we have to mention tectonic activity. We live on a planet with moving plates. Even in areas not known for major earthquakes, the constant slow grind of these tectonic plates creates stress within the Earth's crust. This stress can create new faults and fractures or reactivate old ones, making the surrounding rock more vulnerable to collapse. A small tremor, one you might not even feel, could be the final straw that triggers a significant landslide or rockfall in an already unstable area. Now, how do scientists and authorities know when an area is unsafe? They don't just guess. They use a fascinating array of high-tech tools and techniques in a field called geotechnical monitoring. One of the most important tools is the GPS, but not the one in your phone. We're talking about high-precision GPS stations that can detect ground movements as small as a few millimeters. By placing a network of these stations across a mountainside or a cliff, scientists can track whether the ground is slowly creeping, bulging, or sinking, all telltale signs of impending failure. Another key technology is InSAR, which stands for Interferometric Synthetic Aperture Radar. It sounds like something out of science fiction, but it's real, and it's incredible. Satellites orbiting the Earth bounce radar signals off the ground and measure the return signal. By comparing images taken at different times, scientists can create detailed maps of ground deformation over vast areas, identifying slow-moving landslides that would be impossible to see with the naked eye. On the ground, engineers install instruments like inclinometers and piezometers. Inclinometers are inserted into boreholes drilled deep into a slope to measure any tilt or lateral movement happening below the surface. Piezometers, on the other hand, measure the water pressure within the soil and rock. If that pressure starts rising dangerously, it's a major red flag for a potential slide. And in some high-risk areas, acoustic sensors are used to listen for the sounds of cracking rock deep within a cliff face, providing an early warning of rockfall danger. So, when all this data points to an unacceptable level of risk, authorities face a tough decision: closing a popular tourist area. This isn't done lightly. They have to weigh the economic impact on local communities that depend on tourism against the non-negotiable need for public safety. Let's look at a real-world example. Parts of the iconic White Cliffs of Dover in the UK have experienced significant cliff falls. These chalk cliffs are constantly being eroded by the sea at their base and weathered from the top. Geotechnical surveys revealed large, unstable sections that were at high risk of collapse. As a result, certain footpaths along the cliff edge have been rerouted or closed entirely. While visitors can still enjoy the stunning views, They are kept at a safe distance from the most hazardous zones. It's a proactive measure to prevent a tragedy. Another case is found in many national parks in mountainous regions like the Rockies or the Alps. After periods of heavy rain or during the spring thaw, popular trails are often temporarily closed. Monitoring stations may have detected increased soil saturation and minor ground movements, indicating a heightened risk of landslides or mud flows. Closing the trail for a few days or weeks until the ground stabilizes is a simple but highly effective way to ensure hiker safety. It's not about ruining your vacation. It's about making sure you can come back for another one. The challenge is that these geological processes are dynamic. An area that's safe one day might not be the next. This is why continuous monitoring is so crucial. It allows for a dynamic approach to risk management, where areas can be opened and closed based on real-time data rather than a permanent blanket ban. So the next time you encounter a closure at a natural attraction, I hope you'll see it in a new light. It's not an inconvenience, it's a shield. It's a testament to the incredible science and dedicated work of geologists, engineers, and park rangers who are constantly watching over these beautiful but powerful landscapes. They are using cutting-edge technology to understand the silent, invisible forces at play and making difficult decisions to protect us. By respecting these closures, we are not only ensuring our own safety, but also showing our appreciation for the complex and untamable power of our planet. The Earth is constantly reshaping itself, and we are just visitors here. Understanding and respecting its power is the key to coexisting with it safely. Thank you so much for joining me on this deep dive into the hidden world of geological hazards. If you found this interesting, please give this video a thumbs up and subscribe for more adventures into the science that shapes our world. Stay curious and stay safe out there.